In this animation, we will describe the Haber process. The Haber process describes how to turn nitrogen in the air into ammonia, NH3. This process is named after the German chemist Fritz Haber. He first devised the reaction to make ammonia, NH3, from its elements. The elements of ammonia are nitrogen and hydrogen, and this was about 100 years ago. So the Haber process describes how we can produce ammonia, NH3, starting from nitrogen and hydrogen. And this process is extremely important because ammonia has many different uses, and the most important use of ammonia is to make fertilizers. The raw materials for the production of ammonia are nitrogen. Nitrogen comes from the air. Remember that nitrogen gas constitutes about 80% of the composition of the air. And we have hydrogen. Hydrogen comes mainly from natural gas. The nitrogen and hydrogen must be purified. Then they will pass over an iron catalyst at a high temperature, which is about 450 degrees Celsius, and a high pressure, about 200 atmospheres. And the product of this reversible reaction will be ammonia. So the reaction of producing ammonia is a reversible reaction. We will start with nitrogen gas N2 and hydrogen gas H2 to produce ammonia, NH3. The reaction conditions are a very high temperature, about 450 degrees Celsius, and a high pressure, which is about 200 atmospheres. And we must use a catalyst, which is in this case iron. Keep in mind that this reaction is reversible. What does a reversible reaction mean? Excellent. This means that the ammonia gas produced will break down again into nitrogen and hydrogen. So at any time of the reaction, we will have nitrogen, hydrogen, and ammonia. Ammonia will be removed by cooling the gases so that ammonia will liquefy. So it will change from gas to liquid. Then it will be separated from the unreacted nitrogen gas and hydrogen gas. As shown over here, any unreacted nitrogen and hydrogen gases will be recycled back into the reaction mixture. They will be recompressed and heated before they return to the reaction vessel. And there they will react again with each other on the surface of the iron catalyst. The chemical equation for the production of ammonia is as follows. Nitrogen plus hydrogen will produce in a reversible reaction over iron catalyst ammonia. So this is the word equation. Let's write now the chemical equation. N2 gas, so don't forget the state symbols, plus 3H2, which is a gas as well, will produce in a reversible reaction, and again don't forget to write over here iron catalyst. They will produce 2NH3, which is gas as well. So usually we write the catalyst used above the arrow of the reaction. So again, here we have the balanced symbol equation for ammonia production. N2 gas plus 3H2 gas will produce 2NH3, which is gas. And we will use iron as a catalyst. So let's repeat. Hydrogen and nitrogen gases will be pumped in over here. Then the mixture of nitrogen and hydrogen will be compressed to a pressure of 200 atmosphere and heated to about 450 degrees Celsius. Here we have the reaction vessel where the reaction will take place, and it contains iron catalyst. The mixture of gases emerging from the reactor will be cooled, and then ammonia will liquefy and it will be separated. So we will collect ammonia liquid over here. Any unreacted nitrogen and hydrogen gases will be returned to the reaction vessel via the compressor. This is the Haber process, which should be carried out under carefully chosen conditions to give a reasonable yield of ammonia as quickly as possible. In the next section, we will describe the conditions.